All right, guys, we're on the back side of day 2 notes, okay? Or day 3 notes, excuse me. And number 3 says 2 chords intersecting within a circle form an angle whose measure is 95 degrees. Okay? So we have our circle, and we have 2 chords intersecting. So here's 1, here's 2. Okay? We try not to make sure they pass through the center, because if we do, then they would become central angles. Okay? So 2 chords intersecting within a circle form an angle whose measure is 95 degrees. If one of the intercepted arcs measures 130, so this is one of the intercepted arcs, okay? Following this angle out, this would be the other intercepted arc. Okay? What's the measure of the other intercepted arc? So we'll call it x. Okay? And so we have to realize we have interior angles, and their formula is arc plus arc. Divide by 2. Okay? And so we'll say that the angle, we know the angle, so we'll put 95 degrees in for it, equal to my one intercepted arc of 130 plus the other one, which I don't know. Okay? This is a little bit of a work backwards one, so what I'm going to do is I'm going to put this side over 1 so that I can cross multiply and get 130 plus x equal to 2 times 95, okay? Which is 190. And I'll go ahead and subtract the 130, and x comes out to equal 60 degrees. All right, so this arc here, the other intercepted, is also 60 there. All right, number 4, an angle formed by a tangent and a secant drawn to a circle. So we'll draw our circle. We have one tangent. It should only touch the circle once. Okay? And one secant that goes through the circle twice. So that is a secant because it touches twice. This is a tangent because it only touches once. Okay? So as an angle formed by a tangent and a secant drawn to a circle from an external point measures 45 degrees. So the angle measures 45. If the greater intercepted arc, which is this one here, measures 155, find the measure of the smaller intercepted arc, which is here. So because we're talking about an exterior angle, so exterior angle equals arc minus arc, divide by 2. And we have the angle, so it's 45. And we have the big arc, which has to go first, so that's 155 minus the smaller inner arc. Okay? And again, this is a work backwards one, so I'm going to make this side a fraction so that I can cross multiply and get 155 minus x equal to 45 times 2, which is 90. Okay? I'm going to add x to this side, and I'm going to subtract 90 to this side. Okay? And that way I'm going to get x equals 155 minus 90 is 65 degrees. And that is how many degrees are in this inner arc. Okay. All right, let's take a look at number 5. 2 tangents to a circle form an external point intercept a minor arc whose measure is 150 degrees. So 2 tangents. All right, those are tangents. They're only touching my circle once. Okay, 2 tangents to a circle from an external point intercept a minor arc. So the minor arc is the smaller one, or the inner one. So that's 150. Find the measure of the angle formed by the 2 tangents. We're trying to figure out that. Okay, so we're going to go ahead and say exterior angle equals arc minus arc, divide by 2. We're looking for the angle, so we'll leave that. We don't have the big arc, but what we have to realize, guys, is that the big arc and the small arc form the whole circle. So 360 degrees, take away the 150, is going to leave me 210 degrees for this arc here. So now we can go ahead and replace our bigger outer arc with 210 minus my inner arc of 150, and then divide by 2. Okay? So 210 minus 150 is 60. And 60 divided by 2, our angle comes out to equal 30 degrees. Okay. All right, one last question down here. It's like a big one. It says given circle O, BAF is tangent, secant BCD, radii OC and OA and OD, chord AE, and here's the good stuff. The measure of arc AC is 80 degrees. The measure of arc DE is 60 degrees. And angle EAF is 75 degrees. Okay? They want us to figure out the measure of arc AE. So arc AE, and I'm assuming it's the minor arc because they only use 2 letters. So taking a look at that arc there, hopefully you realize the 75 is formed by a chord and a tangent, and so these act like inscribed angles, and so half the arc would equal the angle, and so that arc has to be 150 degrees. Angle DOC, D to O to C. That's a central angle. And looking around, I have all the arcs now except for that one. So I'm going to take 360 degrees, take away the arc of 60, the arc of 150 that I just found, and the arc of 80. I only have 70 degrees left. And so this arc has to be 70, which then makes the central angle 70. All right. Angle OAB, O to A to B, that is a radius meeting a tangent, which are perpendicular. And so this is a 90-degree angle. Okay. Let's see. Angle OAE, O to A to E. What we realize here is that if that's 90 on that side, this has to be 90 on that side, and part of that 90 is 75. So 90 minus 75 would leave me with 15 degrees. Or I could done 3 angles on a line that add up to equal 180, either way. And my last one, angle DCO. D to C to O, this angle here, we can't follow the sides out since it doesn't go all the way across. Okay? But what we can realize is that this side and this side of this triangle are congruent because this is a radius, and so is this. And 2 sides in a triangle that are equal have angles across from them equal. And so basically we're dealing with an isosceles triangle that has 180 degrees, but 70 for the vertex, okay, leaving 110 for the 2 base angles to split equally to give us 55 degrees for each of those equal base angles of that isosceles triangle. Okay? So this has to be 55. All right. I will see you guys on the next day of notes.